Now, what is population? What is sample? Hello? Can someone try?
Population.
Population?
Population is the entire collection of object or individual.
Yes, that is being studied. Okay. Or if you refer to your video, they don't call it as subject or object. They call it as thing. Okay. So means that what is population is the entire object, subject, or thing that are being studied. Okay, that would be your population. What about sample? What is sample?
Subset of population.
Yes, it's a subset of your population. It's a subset of object, subject, or things inside the population. What is the difference between them? What is the difference between population and sample? So what is the difference? The difference can be in terms of size. Population is greater than sample, right? So that would be one of the difference between population and sample. What else? That would be the obvious one. It just let us stop there. Okay, in terms of size of population and sample. True or false? A sample is a subset of population or objects in a sample is a subset of people or objects in a population.
True.
True or false? True, yes. Okay, what is parameter? What is statistic? What is the difference between them? What is parameter? Parameter, statistic. What is parameter? What is parameter? We call it as what?
Measure.
Huh? What was that?
Summarize data.
No. Summarize data
Population.
is a numerical summary of population. Okay? It's a numerical summary of a sample.
Sample.
Yes. For example, what? What parameter can you say first? Population what? Population size. What was that? N. What about population sample size? Plus sample size is N. What else? Population mean. What is the notation for population mean? Plus, huh? Mu. What about the sample mean?
X bar.
X bar. What about population proportion?
True. P.
P, capital P. Sample proportion? P
Prime.
hat. P hat. Or P prime. Also can. Population variance. What is population variance? What do we call this? No, sigma squared. Sample variance?
S squared.
S squared. So all these are parameter and statistic reflecting the numerical summary measured from your population or from your sample. What is the difference in terms of the notation? Obviously, we can see the notation. The notation will reflect to the subset and to the total of your population. Now, what? True or false? A parameter describes characteristic of a population of interest. True or false?
True.
That's true. Yes. Explain the difference between descriptive and inferential statistics. Question number 5. What is the difference between inferential versus someone is not muting, okay? Inferential and descriptive. Now, what is the difference between descriptive and inferential? Okay, class. What
Collect.
about this? Huh? What was that? Collecting what? What? Now, this one is your understanding of what if I have my data and then what should I do with my data? Then this is your understanding that you need to have in order for you to identify what kind of method and analysis that you should choose for your data, for your secondary data. So descriptive statistic tells about what? Describe, okay? Describe your data by summarizing it using what? Graphical
Or numerical analysis.
or numerical analysis. So graphical, you got a lot. Box plot, pie chart, bar chart, etc., etc. Numerical, you have measure of central tendency, MCT. You have also measure of dispersion. And lastly is measure of position. So we are going to look at it simultaneously. Okay, so which one comes first? Then we will discuss that one. So that is descriptive statistics. Okay, what about the inferential statistics?
Inference about the population using the selected sample.
Yes, making inference of your population using sample using data from sample. Okay, making inferences of what? Making inferences could be for the population mean and for the population proportion, for example. So how are we going to use the sample to make the conclusion for the population mean and proportion? Then we are going to use our X bar and our P. Sorry, this is capital P. This is the P hat. Okay, so that is the difference between descriptive statistic and inferential statistic. So in this case, it includes making conclusion. Okay, making conclusion for the population. Here, you just making conclusion for your data only, which is from your sample. Okay, now question number 6. True or false, the purpose of inferential statistics is to simplify and organize the data from a research study. True or false? Class. The purpose of inferential is to simplify and organize. Is it correct?
True.
True. Look at your inferential. Are we going to simplify?
False.
False.
False, right? Because we are making inference, we are making conclusion. So we are not summarizing and we are not organizing. We are making inference. So this is false. Okay. Give an example of a variable. Why it is called as variable? Number 7. Okay. Give me one example of variable. Few example of variable.
Length.
Length. Next.
Weight.
Weight. Categorical. Categorical. What else? Length, weight. What else? Any other example?
Concentration.
Concentration. So concentration will be, okay, concentration. So that will be on solution, right? Concentration. Right. Solution, right? I mean, percaya. Concentration, kepekasan. Right. Okay. Any more? Give me categorical variable. Hmm? What was that? Gender. For example, middle. Middleist. Okay. So here you are talking about quantity. Quantitative data. So this also quantitative, this also quantitative. Okay. Here we are talking about qualitative. Qualitative. The same goes here. But among gender and medalist, okay, medalist means you have gold, silver, and bronze. Gender, you have male, female. Now, which of the categorical or qualitative data is nominal? Which one is ordinal? Which one is nominal first? Which one is nominal? What is nominal? Means that it will not be in order. No rank, gender. So this is your nominal variable. What about medalist? This one is an ordinal variable. Means that because gold must come first, then only followed with the silver and finally the bronze. Okay, so it is in order. So that would be simple example of what variable and why it is called variable. Why it is called variable? Why variable?
Benda yang diukur.
It's your measured interest, right? In simple way. The variable is your measured interest. Okay, or characteristic or criteria of your interest, study interest. Number 8. Okay, number 8. Give example of qualitative variable and quantitative. So we have discussed that. Briefly explain the difference between observational and experiment study. What is the difference? Why it is important? Okay, that would be question number 9. Observational versus experiment. What is the difference? Both are doing observation, right? We observe. Here we also observe. But what is the difference observing in observational study and observing in experimental study? Plus, in experimental study, we include our attempt to the subject. Right. Okay. Attempt to the subject. Okay, because If you are talking about trees and you are using different fertilizer, so you're going to use different fertilizer for different trees, and you will at the end of some season you will look at your yield of each of the tree, and you would like to see there will be differences of types of fertilizer used towards producing more yield, right? That would be such as attempts to your experimental study. So in observed variable, in observed study, data is collected as it is. Okay, means that you observe, you record. You are not going to change the data because everything is based on the observation. But in your experimental study, so your data will be collected based on the attempts that you do. Okay, so you get your result. Okay, data that is affected by the attempt you made in your experiment. Now, number 10. Number 10, number 11, I think I'll just disregard there. Okay. This earphone is killing me because killing saya. Okay, number 10, I just disregard. Okay. The same with number 13. Okay. When one examines the entire population instead of a subgroup of population, this is called what? Class. When one examines the entire population instead of a subgroup of the population, this is called
Raw data.
no. You examine the entire population. This is called parameter is almost correct, but we are talking about the when one examines the entire population instead of a subset of the population, this is called a if I'm not mistaken, this is a census bunching. Okay, and the result of this measured characteristic would be parameter, if I'm not mistaken. Okay, examine the population. Yeah. Okay, number 15, disregard. Now, number 16. Which of these measure, mean, mode, median, can be more than one value? Which of these one can be more than one value? Plus, how to calculate mean, mode, median? So in order to answer that question, you have to ask, how do we get our measurement? Okay, so that would be question number 16. Mean, mode, median. What is mean? What is mean? How to get mean? It's the summation of xi divided by n, right? And you get your x bar. Your mode is data with the highest frequency. Right. That will be the mode. The median will be the 50th observation in your data set. But the data set must be ordered. Okay, ordered data. Ordered data set. Means that you have to arrange from the lowest to the biggest value. Then only you find the 50th observation. And this will reflect whether your n is odd or your n is even. Okay, nak janji. Okay, Now, from this, which of the mean, mode, median can have more than one? Tell me.
Median.
Median? Wrong. Median will always be one value because it will always refer to the 50th value. The same to X bar, one value only. Okay? One
Can
value.
madam.
What was that?
Mode. Is it
Yes.
mode?
Yes.
It could have same two frequency, highest frequency.
Yes. Yes. Because this is the one. Mode can have more than one. Okay? If, for example, you are talking about 2, 2, 2, 3, 3, 5, 5, 6, 6, 7, 7, 7. So here, what is your mode? What
7.
is your mode?
2
2 and 2 and 7 because here got 3, here got 3. This only 2, 2, 2. So your mode is 2 and 7. What if I have 2, 3, 5, 6, 7? What is your mode? What is your mode?
2, 3, 5, 7.
Are you sure?
7, 7.
Are you sure? Look at the most frequent number. Which of the number got repeated number?
No mode, madam.
Yes, the answer, if you answer 0, then this is wrong. The answer is no mode. Okay, so in this case, you have no mode. Okay, question number 17. I started feeling exhausted because I spent almost 2 hours for my class with RK24 just now. I finished my class at 3:25 actually. Okay, I hope I still can have the momentum until we finish the class. Okay, now we finish number 16. Now look at number 17. By using box plot, how to determine shape of a distribution and description of a distribution. Okay, so now we are specifically talk about the box plot. What is box plot? Box plot is one of the graphical form that you can use to represent your data. Okay, so in details we are going to look at in the next questions. But to answer the question, question number 17. The question is, by using box plot, how to determine shape of a distribution and dispersion of a distribution. So the question got two things being asked. First, how to use box plot to determine the distribution. What distribution? So you can have either symmetric, or we sometimes call it as normal, or skewed. Skewed can be two, either left skewed or right skewed. Okay, so we are going to use box plot in order to determine this one and this one. How to use that. And on top of that, we are going to see how the dispersion, okay, can be tell from the box plot itself. Now, let us look at this particular example. Okay, I believe and I'm sure that this point has been discussed in two of your videos that show the box plot, how to formulate the box plot and the 5-number summary. Okay, now when you are talking about box plot, you are also indirectly talk about your 5-number summary. And what are they? They include the minimum value, the maximum value. So got 2 now. Now, if let's say we have the middle, so this is your Q1, this is your Q3, and let's say this is your Q2, which is your median. Now, this is your first box plot. How can a box plot help you out in terms of giving you the hint what is the distribution of your data? Let me draw the next box plot so that you can easily what we call conclude on each of the box plot. This is your first box plot A. You got box plot B. So you have min, max, and then you have one, two, three. Okay, and then the other one would be C1 would be are you guys with me? Samsu, quiet.
Ada pun ada.
Okay, and then this is what I don't like about what we call online class because I don't see what you guys doing. So Q1, Q2, Q3. Now, what is the difference? Tengok. Okay. I want to make a different one. Okay, so let's say this one, this dekat, yeah. Sorry, my pen, I cannot erase my. Okay, so this is your new. Now, let us look at this tree. Now, in your video, they say you can base your box plot to tell you on the distribution of your data. It's either you use first the whiskers or the boxes of 50%, middle 50% of data. Which box? This is what we call whiskers. So this is whiskers. Okay, this is whiskers. This is your whiskers. Now, this is your box. Box 1. This is box 2. Now, you can base on either of your whisker or your boxes size. Or you can either use either one or you can use both depending on your box plot that you have. For example, in this case, now it is obvious that the box here is larger and the whiskers compared to here is larger. So in this case, we can say that your is skewed to the left. Sorry, skewed to the right. Skewed to the right. Because this box is what we call larger than the other box, second box. Or, for example, in this case, your second example shows everything is almost equal. This one is equal with this one. This one is equal to this. So if you see this is what we call symmetric data. Symmetric or normal distribution. Okay? Now, we haven't commented anything yet. We just try to figure out using your box plot. Now, third box plot. We can see almost equal box, but larger whiskers here. So, in this case, we can have what we call skewed to the left. Okay? So now, what can we conclude from this? The question just now, by using box plot, how to determine shape of a distribution and dispersion of a distribution. Determine shape and dispersion. So you can say by using the whiskers based on the length and using the middle 50% of data that is referring to two boxes. Okay, we can determine the distribution and what dispersion of a data. So in terms of dispersion, definitely you are talking about this until this. How spread is your data? Is either using range. So if you are using range, then you have to max minus min. If also you can use this one, middle 50% of your data. So this is your what we call IQR. And IQR is obtained by Q3 minus Q1. Okay, so on top of this, okay, IQR can be used to describe the dispersion. Okay, that would be your second answer. Okay, understood class. So in a nutshell, we can say by looking at the whiskers, which whisker show longer whisker, it will guide you to the tail of the distribution. Okay, by looking at the box of your middle 50%, why I say middle 50% class? When we divide our data into box plot, meaning that we have 25% of our data lies between this and this. Another 25% is here, from here to here, and another 25% is here to here, and another 25% is from Q3 to maximum. So that's why we call it as middle 50% from here to here. Okay, class? Any questions so far? Any questions? No? Okay. Okay, next question is question number 18. Okay, number 18. Let us look at question 18. Explain the relationship among measure of central tendency for a skewed distribution and symmetrical distribution of a data set. Okay, so you are talking about measure of central tendency of a skewed and symmetric distribution. Okay, relationship among measure of central tendency for a skewed and symmetric distribution for a data set. Okay, let us look at the question 18. Okay, question 18. Now, when we talk about what we call this one, what was the question? Measure of central tendency for a skewed and symmetric. Okay, so let us illustrate in terms of two different distribution. Let's say you have your symmetric and you have your cube. Okay, second one. Okay. Now this is symmetric. This is left skewed. This is right skewed. Now, what about those measure of central tendency? What do we mean by measure of central tendency? And what does measure of central tendency refers to? We know MCT contains mean, mode, median. Correct, right, class? Is it correct, class? Class, MCT is
Yes.
mean, mode, median, right?
Yes.
Now, what if you have symmetric or normal distribution data? What happened to your mean, mode, median? Now listen carefully. Okay, so let's say I put this x bar, this is mode x hat, and this is median x curly. What happens if we have symmetric data or normal distributed data? Everything will fall in the same line. Means that your x bar is equal to x hat is equal to x curly. Means that your measure of central tendency will only have one value. Means that the mean is equal to the mode is equal to the median. That's why we call it as measure of central tendency. So for symmetric or normal distribution, what is the best measure of central tendency? The question, next question. What is the best measure of MCT among the three? What will be the best? Remember class, the best will always the mean. Okay, will always the mean. Not mode, not median. Okay, so what happens if you have skewed data? How does that value different from each other? Now, if you have, please relate to your foxtrot just now. So if, let's say this is your median, so this is your median, and this is your median. So for left skewed, your mean will always be smaller than your median, and your, what we call, mode will always be larger from the rest. This is your X mode. Okay, so left skewed data means that your measure of central tendency will have different value where the mean is smaller than the median, and the median is smaller than the mode. How do I know? Imagine this is your x-axis, this is 0, from 0 until certain value. Of course, as you go along with x-axis, the value will be increasing. So that's why we say mean will always smaller than the median, and the median will always smaller than the mode for left skewed data. For right skewed data, it will be reversed, but median still at the middle. So you will have your mode, you will have your median, and you have your mean. So in this case, for right skewed data, the mode, okay, the mode will always be smaller than the median, and the median will always be smaller than the mean. Okay, understand class? So that is what question number 18 is asking me. Okay, number 18 or 19, 19, sorry. 19, explain the difference between measure of central tendency and 18, sorry, class. So number 19, class, number 19, explain the difference between measure of central tendency and measure of dispersion. How can you say, sorry class, I have important message, I need to reply. Okay, so for question number 19, what explain the difference between measure of my son? Oh, you go to class. You go to class. You go to class. Tak lagi buton. Okay, what is the difference class? Measure of MCT and MD. Class, this is very simple. Can you give me your answer? One of you, please. Explain the difference between. What is the difference? Can someone try? No? Can someone try? What is the difference between MCT and MD? Class?
Kejap, Wan.
What is, okay. If I draw, let's say I draw talking about symmetric data, okay, or skewed data. MCT, okay, MD. Can you say something about this?
Madam,
Hmm.
if MCT, they have to find mean, median, and mode. If MD, we have to find the range, variance, standard deviation, and so on. Is that true?
What was that? What was that? Just again?
If MCT, we have to find mean, mode, median. If
Mhm.
MD, we have to find range, standard deviation, and variance.
Okay. uh, you can also say that, but that one is not an what we call universal answer. Okay. MCT MCT tells, okay, tells the middle values represented by x bar, x hat, mode, and x curly median. Okay, but for MD tells how your your data is uh, is uh, is is distributed or spread. Means that MCT only tells the middle value, which can be either the mean, mode, and median. But measure of dispersion tells how much your data is spread from the beginning to the end of your data. And that spread can also be described by using your range, the easiest one, that will be the maximum minus the minimum, or by using your variance. And from variance, you can get your standard deviation. Okay, so standard deviation if we are talking about what we call symmetric data, then it is the deviation of each data from the middle value. This is your X bar. Okay, so that is your measure of dispersion. Okay, so means that how to get my dispersion? If variance, it is S squared. It is obtained by sum all the xi minus the x bar where I from 1 until n. Means that from the smallest until the largest value divided by n minus 1. So what happened is that this is all your points. Okay, data point. And this is your mean, sample mean. So what happened? We are going to, so you have your data set here. You have your data here. So what happened? We are going to measure each and every distance of your data to your X bar here. The same goes here. So if you deduct, for example, if let's say this is 10, this is 20, this is 40, sorry, 30. Okay. So these values are smaller than the average value. So that's why we have here is the negative distance. Okay. And this one is positive distance. And because of we have negative distance, we square them to make sure that all will go back to your positive value. Okay, so that's why we measure the dispersion. Because the measure of central tendency and the measure of dispersion give different meaning to your data. Okay, so it is good for you to know how the measure of central tendency for a data reflect to the dispersion of a data. So this will tell you the whole story of your data. Now, number 20, is it possible to get negative value of standard deviation? By looking at this, so standard deviation is the square root of this particular thing. So standard deviation will always be positive. Okay, your S is always positive. Okay, question number 21. Explain how to calculate interquartile range. How do you describe IQR? So look at your question. So I don't need to scroll up and down. So question number 21 refers to your IQR. So when we talk about IQR, so remember the 5-number summary and the box plot. So you have this mean, max, okay, and then you have your middle 50%. So let's say this is your Q2, Q1, Q3. So what is your IQR? Simply IQR is equal to Q3 minus Q1. So it is the range of this particular middle 50%. Range of middle 50% of your data. Okay, so that is IQR. What's the next question? How to calculate? Then, how do you describe IQR then? Okay, IQR describe the middle 50% of my data. Okay, understand class?
Yes, madam.
Okay, now I feel so much time has been spent for part 1 only. I haven't gone to part 2 yet. So question number 22. For a given box plot, how do you interpret the median in the bracket second quartile, first and third quartile? Now, this is what we call further detail for this particular problem. So number 22, you are talking about median of median of second quartile, median of Q2, median of Q1, and median of Q3. Now, what is this actually? Median of Q2, median of Q1, median of Q3. Now, class, if we are talking about this, I use this illustration for this particular example, question. Median of Q2, we are talking about Q1, Q3, and the median is Q2. This is median of Q2. Reflect the middle 50% of data. Right. What about Q1? Where's Q1? Here's Q1. Means that for Q1, we are talking from mean to the Q2, which is half of the box. And this is your Q1. So what is Q1 here? Q1 is the median of lower 50% of data. Understood, class? So just now is the middle 50%. Then come, what is the median of Q1? Median of Q1 is this one. What is median of Q1? Is the median of the lower 50%. This is lower and this is upper. So definitely for Q3 is this is Q2, this is Q3, this is max. So median of Q3 is the median of the upper 50% of data. Understood, class?
Yes.
Okay. Now let us finish quickly. Number 23. Which measure of dispersion, range, standard deviation, or interquartile range would be best for a skewed distribution and symmetrical distribution? Can you draw your box plot for symmetric and box plot for skewed? Class, draw your symmetric box plot and skewed box plot. Number 23. So the question asks, among range, standard deviation, and IQR for symmetric and skewed. Which one is better? Best for skewed and symmetric of a data set. So let's say if you draw your no need the box plot. If you draw your distribution symmetric, distribution skewed, for example. Okay. Now, what will be the best measure for dispersion? For dispersion, measure for dispersion. Now, for symmetric, first class. For symmetric, we have discussed this earlier on. Which one is the best? Range or standard deviation or IQR? Which one is the best? So this one, range or standard deviation or IQR? Class. First, symmetric. Which one? Is it range?
IQR.
IQR. Measure of dispersion for symmetric and skewed. Usually, for symmetric, okay, IQR is also correct. It depends on the discussion of your answer. If you're talking about overall, what we call overall data, standard deviation is the best because standard deviation will calculate the value of the dispersion from the minimum value to the maximum value, taking into account all single data that you have in your data set without miss. Okay, so maknanya the standard deviation is the best in order to measure the dispersion of your data from here to here. If you are referring to the middle 50%, then IQR can be the answer. Okay, but at the moment, standard deviation would be the best. What about for skewed data set? Remember, when, what was that?
IQR.
Yes, IQR. Standard deviation is no longer suitable because it's already skewed. Okay, and the range also can be questionable because IQR will always go back to the middle 50% of your data. And some more, if you have skewed data, it could be an outlier here. Okay, if it is an outlier, this could be very small value. If you have very small value, what happens is that your standard deviation will be affected because each and every single data will be calculated in the standard deviation. But IQR will not going to consider any data below this. The same goes if you have right skewed data. So the middle 50% would be somewhere here. If you have outlier here, this will not be considered since we are going to focus in the Q1, Q2, and Q3 here. Okay, so that is number 23. Number 24, is the mean or median a better measure of central tendency for a data set with outlier? Now, we are talking about this question number 24. Is the median or mean? Now, the question, mean or median for skewed data. Means that you have outlier here. Which one is better, mean or median? Class. We have discussed earlier.
Median.
Why median?
Median. Because
Yes.
the center.
Center. The center what?
Center of mode and mean. It's always in the middle of mode and mean.
No. Okay, that will be reflecting your distribution. But if you are talking about mean mode median, what happened, class? Mean will always consider summing all the xi divided by n. So if your xi contain outlier, so this will be affected. But median will not be affected. Why? Because you are talking about the position of 50th value, okay, 50th data in an ordered data set. Means that it always be in the middle because it is the 50th value, exactly in the middle. So if you're talking about odd, so the median would exactly on a number. If you're talking about even, it would be in between two values. And you have to find the arithmetic mean of the two values to get your So that's the difference between mean and median. So for skewed data set, median always be the best. For skewed data, median is the best MCT. Just now, for symmetric data set, for symmetric data set, mean will be the best. Okay, so that are among the conclusion that you can keep in your mind, so that next time you can understand the difference between those measure of central tendency and dispersion. Now, last question, number 25. Do range affect outlier affected by outlier? Number 25. We're talking about range. Yes.
Yes.
Why?
Yes.
Why?
Range always in at the data.
Huh?
The range is always end of the data.
Okay. Now let us, okay, thank you for the answer. Good try. Okay. Now range is the max value minus the mean value. And if you are talking about a data with 2, 2, 3, 3, 3, 5, 5, 5, 5, 8, sorry, 8, 8, 8, 8, 15. Okay, how many n here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lebih berapa ni? 2, 2, 3, 3, okay. Padam satu. So you get 12 here. So this means that you have even sample size. Even mean genap. Okay, bila genap, okay. So before we go to range, okay, range will be what? Sorry, we go to range first. Range will be 15 minus 2. If you look at your data set, it shows that your last data seems to be an outlier because with the rest of the data is from 2 until 8. And suddenly the dispersion from 8 to 15 quite big. So in this case, we may consider 15 as your outlier. So in this case, what happens is that if you put 15 as your last or maximum value, so you will get your range is 13. What happens is if your data end up with 8, okay, let's say this is your last value, maximum value, so your range will be 8 minus 2, you got 6. You see how big is the difference between with outlier and without outlier. So this with outlier, this one without outlier. So means that range is affected by the outlier. Because range use the maximum value minus the minimum value. So whenever we have minimum, if the minimum is the outlier, then the range will become affected. The same goes to if your outlier is at the maximum value. Okay. Now, let's extend the example here. From this example, what is your mode? Class. Can you tell me what is your mode? Considering 15 is included.
5 and 8.
Are you sure 5 and 8? Are you sure 5 and 8?
Only 8.
How many 5? Only 8, right? Because 5,
Eight.
only 3. This one, only 4. So this one is not included. What about your median? Okay, median must be ordered data. So please order them first. So since this has been ordered for you, so what will be your median? Your median would be the middle value. So since your n here is 12, even, So it will be between 6 and 7. 6 and 7 data. So 1, 2, 3, 4, 5, 6. So 6 here, 6. 1, 2, 3, 4, 5, 6. 6 here. 1, 2, 3, 4, 5, 6 here. Okay. So this is your 6 and this is your 7. Okay. Your median will be 5 plus 5 divided by 2. Coincidentally, you got between 5, so definitely it is 5. So your median is 5. Okay. So what if I reduce? Okay, let's say I have only 2, 2, 3, 3, 5, 5, 5, 8, 8, 8, 8. So now you have 11 samples. Now, then this is an odd. Okay, so it will definitely fall in on a number. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So exactly this is your median. Okay, so that is quickly on how we can find the median, mode, and mean. So the mean, definitely the mean x bar would be summing all the data value 2 plus 2 plus 3 until plus 15 divided by 12, and you will get 6 as your x bar. Okay, so if you can see, almost the same for the value, the mode, the median, sorry, the median, yes, and the mean. Okay, finish with chapter 1, part 1. Let us look at part 2. Okay, so I need to bring this up. Look at question 11, part 2. Now, question 11. Now, this is question, this is part 2. Question 11, right? Okay, a little bit more before we can stop. Okay, initially I was planning to finish all the tutorial and then go to the analysis using Excel. But it turned out that we spent the whole time discussing on the tutorial questions. I think it is best for me to discuss the tutorial so that you have the feeling of how you can interpret from your numerical and graphical analysis that you may have for your data. So I think it's good to have a discussion on the tutorial. Then in the next class, next week on Wednesday, we are going to do hands-on, what we call hands-on Excel exercise on how to, from raw data to organized data to frequency table to graphical and numerical analysis of your data. Okay, let us finish this question 11, then we finish the class. And we have more or less 30 minutes before we finish the class. Huh? Now, look at these two box plots. And we have box plot for class A and for class B. Okay, can you give me what is the variable involved in this particular question? Can someone tell me what is the variable? Variable is equal to what?
Score.
Huh?
Score.
Score and
Good.
class.
Yes, good. Score
Class.
only. Class, no. Now, class is not your variable. Class is your categorical for your consider also as yes. Class is also a variable reflecting your categorical variable. Okay, thank you. So your variable first is your for and your class but not class A, class B, class only. Score is your quantitative variable and your class is the qualitative variable. So you can imagine your data set that you got for your project 1 may have this particular what we call dimension inside your data set. So whenever you have different representation of data, you need to figure out which can be my variable, which can be my sample, and how many of them. So you can ask that, okay? So in this case, you have two variables, quali and quanti. Describe the data distribution for both classes. Now we have talked a lot about the box plot. Okay, describe the distribution for both classes. So now you need to describe the distribution. If you're talking about the distribution, it's either symmetric or normal or skewed. Either skewed to the left or skewed to the right. Now, what can you say about both? Yeah. Describe the shape of the distribution for both classes. So let's say begin with class A, class B. What about class A? What is the shape? Look at the whiskers, look at the boxes. So let's say the median for this for class A is this, and the median for not really sure. Is it at the middle class? For the second class, somewhat almost the same. Huh? Okay. Now, can you tell me from a box plot class A, is it symmetric or is it skewed?
Skewed right.
Skewed to the right or skewed to the left?
Skewed.
Look at the whiskers. The whiskers seem to be longer at this area. So, and then the bob also, this one is larger than the other one. So it seems
Skewed
that,
left.
yes, skewed to the left. Skewed to the left. What about class B? What about class B? The whiskers almost the same. The box also almost the same lah. Can say that way. So what can you say about the distribution of your class B?
Symmetric, madam.
Yes, symmetric. Approximately symmetric. Sebab kita nampak macam ada beza sikit. So approximately symmetric. Okay, or normal. Okay. Support your answer. Now, how you support your answer? You can say here, longer whisker towards the minimum value. Can say that way. Minimum data. Okay. And here, you can say almost equal length almost equal length for both whiskers in the left and right. So means that we are talking about the whiskers almost the same, the box also almost the same. So we can say that is why we state approximately normal. Compare the median between class A and class B. So what can you say about median class A and class B? Clearly class, yes. This is your Q2. This is your Q2 for class B. What can you comment on the median of class A and class B? Class, are you all there? What can you say? The median. Hello? What can you say about the class of A and B, the median?
Median class A has higher score than median class B.
Yes. Median score of class A is larger than median for class. So means that class A is better or class B is better? Class A is better or class B is better based on the median? Which one is better, class A or class B?
A.
Why A? Because the score is larger. So in terms of median score, A is better than B. Okay, what was the question, right? What can you say about the mean value for class A and what makes you say that? Okay, number 4, mean value for class A. What was the distribution of class A just now, class? What was the distribution? What was the distribution of class A? Class? What was the distribution? I know the distribution is here. What was the distribution? Class? My ear is killing me now. Yes, I need to finish my class earlier. Can you tell me what is the distribution of class A? Class?
To the left.
Left skewed. Bila left skewed means that you have this particular. So what can you tell about the mean when you have left skewed? Remember the condition of mean, mode, and median for left skewed. What is the value for the mean?
Lesser than mode and median.
What was that?
Less than mode and median.
Yes. For this particular what we call distribution, mean will be less than the median. And we know that the average score for class A is lower than the median. Right. Okay, so from here we can say the average score of class A is lower than the median of score. Median score of the median score. Okay, class. So my next question, This is my additional question. Between mean and median, which is the best measure of central tendency to represent score for class A? Class. Those who understood the previous discussion can easily understand and can easily know what is the answer. Between mean and median, what is the best measure of central tendency? What was that?
Median.
Yes, median is the best MCT. Why? Because
In the middle.
no, because the data, because the distribution is skewed. Median, yes, it is in the middle. But for this particular question, the correct reason is because of the distribution is skewed. Whenever it is skewed between mean, mode, and median, always median is the best MCT for skewed data. Okay. What like? I can't wait to finish everything. Okay. Which class? Do you have information of the mode? Do you have information about the mode class? Question number 5. Is it 5? Yes, 5. Do you have any information about the mode? Let's say mode for class A. Mode for class B. Now, we know that class A is skewed. What is the value of the mode? Class, remember the concept of skewed reflecting the MCT, mean, mode, median. Now, what is the mode? Do you have information of the mode for class A?
Mode is bigger than median and mean.
Yes. So for class A, mode is greater than the median. Okay. What about class B?
Equals to mode and median.
What was that? Almost?
It is equal to mode and median. Same value.
Yes. Yes. Mode is approximately equal to the median and mean. Almost there. Okay. Which class with smaller dispersion? A simple question. Which class smaller dispersion? From here. Class A or class B? Smaller dispersion class. What was that?
Class B.
Yes. Class B, smaller dispersion. Why? Support your answer.
Because the box stat is smaller compared to class A.
Yes, smaller dispersion because you can say it's either you show the calculation. If you show the calculation, you can guess that the what we call the IQR, if you are referring to your IQR, so this would be 60 plus B is 65.9 minus 64.6, which is 0.3. In here, IQR is equal to 67 minus 64, which is equal to 3. So this is why, that is why class B has smaller dispersion. You can also use range. Okay, never mind, can be used also. So find your maximum is 67 minus your minimum is, let's say, 63.4. Okay, you will get the range. Also can, so you have to find the range here. Okay, so that's how you compare. What can you say about the IQR for class A and class B? Oh, this is the IQR. Just now, The IQR is for question 4 plus the IQR. Okay, which class will follow this question? So I just based on the range can also be done. Okay, support your answer IQR, then you have to calculate. Okay, so the dispersion can be by looking at the range, by looking at the middle 50%. Okay, so I think that's it. I have class start from 1:30 non-stop. Continue with your class. So for your next class, I'm going to what we call assign you on what we call key in question number 13 to your Excel. I'll give the direction to you. Okay. Now did I give you the attendance for videos last night class? Can someone reply? Did I give you the question the Google form for attendance?
I think
No.
no. Rasanya
No.
tak ada pun.
Okay, it's okay. I'll give you the attendance, and as usual, I'll give you some time for you to have a look on the video and to answer the Google form as your attendance proof. Okay, for today's attendance, everything is recorded in your WebEx. Okay, so do you have any more questions before we stop?